section. The next section, on which is now page 147, discusses this idea of Charles's law and Boyle's law. And all these things do is talk about this idea of constant pressure means V over T equals V over T. The pressure's canceled out of our favorite equation. Or for constant temperature, we'll call it Boyle's law, and PV equals PV. That's Boyle's law and Charles's law. So you can see it here. T over V is constant. That's Charles's law. And PV equals constant. That's Boyle's law. I wish I could do something that simple and get my name in every textbook in the world, but honestly, I wouldn't much care. So the laws are these things about what's constant and what's not. And then based on those laws, we can make these other discussions. For constant pressure, the work is that pressure times whatever volume change there is. In a constant volume process, there is no delta V. Nothing's being moved, so there's no physical work being done. We have to have physical movement to get physical work, right? So PV is the energy due to, or P delta V is the energy change due to physical movement of a liquid. Liquid or gas, either one. Isentropic process, PV to the K, we mentioned that, and here's how you calculate the work. So that's somewhat of a handy equation potentially. And for constant temperature, we know PV is constant. Here's how you calculate the work for that. And then if the exponent is something other than 1 or other than K, there is that. These equations are all fairly similar. And I guess I'm not going to go into derivation of this, given how limited a topic this is for your exam. Grab it, plug it, play it, move on. So we have some sample questions here. It expands from V1 to V2 at constant pressure. So V over T equals V over T. I've just eliminated the P from my favorite equations. Plug in the 1 and the 2, I can find the temperature. What I'm being asked to do here is say, what is the work done on the system? So as soon as they say constant pressure, I'm looking right here, and I know it's P times delta V. So we'll just plug in those values. P of 200 and delta V is given 12 kilojoules. So your biggest problem with these questions is not that sort of the brain work is heavy or that the algebra is difficult. You just got to find the right equation, essentially. Now, there are ways that if you're really familiar with this stuff, you can remember more and more of this stuff and not have to look it up. But for what we're doing here, trying to pass this exam with 1 or 2 thermo questions on it, we just need to concentrate on where to look. So where do you need to look to find the work done by a constant pressure process? Well, you need to type in the term constant pressure into your search and see if that leads you here. It's interesting that this is listed as constant system pressure, so you'd have to check and see if that word system in there prevents you from being able to search for that one. But certainly if you typed in constant volume or isentropic, you get a short list of equations that it would lead you to.